Alright guys, here we are with 9.5, day 2 on hyperbolas. Okay. Today is going to be more about the graphing. Yesterday we kind of had to do some little sketches on the graphs to be able to come up with the equations and to come up with all the points that we had. Okay, now we're actually just going to have the equation and you're going to have to graph it. Okay. So our first one we're looking at on your note sheet here, number 2a, we have y squared over 36 minus x squared over 16 equals 1. So a couple things I can tell just by looking at that. Number 1, y squared first means this is going to be an up and down one. Second, there's nothing in here with x and y, so that tells me my center is at 0, 0, which is super nice. Okay, center 0, 0. My a value we're going to have with x, so a squared is 16, regular a is 4. Nope, you can't see that. Sorry, guys. Okay, and the b squared that's with y squared is 36, so b is 6. Okay, this tells me a couple things to do here. Alright, so this one's my one that's going to be going up and down. So 6 is the distance from the center. 2, 4, 6. 2, 4, 6. Notice that we're going by 2's to get to my vertex. Those are going to be where my individual ones are going to be coming from. A is 4. That's my side to side. 2, 4, 2, 4. These don't really do anything, but they do help us make our box. So this is going to go up to here. So we have a corner here, a corner here, corner here, corner here. Now those corners aren't actually points that we're going to have to write down, but those corners are going to be helpful with our asymptotes. Oh, I should have done dotted lines. Sorry guys, asymptotes are dotted. I'll do better on this one. Because those lines aren't included as part of the graph. Okay? So now we can draw our individual pieces following our asymptotes on the way out. Okay? So there's our graph. What else do we need for our graph? We're missing our focus points, our foci. Okay? So remember, for hyperbolas, c squared equals a squared plus b squared. Our a squared was 16. Our b squared was 36. Okay, so we're going to have, this is 52. C then is the square root of 52. Break down your radical. Square root of 4 times the square root of 13. That's going to be 2 radical 13. So for our decimal graphing purposes, this is about 7.2. And then for our exact point purposes, we'll leave in the radical. Okay? So 7.2 up. So 2, 4, 6, 7 is right there in the middle. 7, okay. That's not an exact one. We should probably label that 0, 7.2, 0, negative 7.2. Okay. And the rest of those all fall on exact points, so I'm okay with that. Alright, we need to know what our vertices are. Pretty easy when your center is 0, 0. So that was just 6 up, 6 down. Right, because it's y. It's an up and down one, so square root of 36 is 6. So this is going to be 0, 6, 0, negative 6. Co-vertices, they don't really get used just in helping with the box. That was 4 out. So that's 4, 0, negative 4, 0. And our focus points. Okay, so starting from our center, 0, 0, Okay, this was an up and down one. We had 2 radical 13. So we're going to do plus and minus 2 radical 13 to the y. Okay, so we're going to have, and this is easier because it's 0, so it's just end up going to be plus 2 radical 13 and minus 2 radical 13. So that's 0, comma 2 radical 13 and 0, comma negative 2 radical 13. Last thing is asymptotes. Plus or minus b over a, so 6 over 4 times x. Now, if you were doing this first, before we did the graph, okay, I would leave it at 6 over 4 for this part, because this is going to be up 6, 2, 4, 6, out 4, 1, 2, 4. That's where the 6, 4 is going to be pretty helpful. But if you've already got this done, like we do, then we're going to need to reduce this now to plus minus 3 halves x. For, like if there was a question like, what is the equation of the asymptotes? Then on the answer blank to this side, you would have to have this fully reduced. The 6 over 4 would be helpful in this aspect of it. Okay? But if you're going to put it on the answer blank off to the side, you would have to have this. Alright, I think that's it. That's everything we can have. Graph each hyperbola, identify vertices, foci, and asymptotes. So we got those. Cool. Next. Okay. Ooh, this one's kind of tough. Okay. So if you have something like this on your homework today, you could probably just write that down by the graph, and you should be able to do, well, you're going to probably need to have this on a separate sheet of paper too, because otherwise it's going to get pretty crowded. So let's just plan on that, having a separate sheet of paper. Otherwise, for these, you would definitely need to be doing your work on a separate sheet of paper, because that's going to take about 4 or 5 lines of work just to get it to where we need it to be. Okay? So let's zoom on in here. Okay? So we're starting off with 9y squared plus 18y minus 16x squared plus 64x minus 199 equals 0. Okay, we want to get our x's together, our y's together. They pretty much are. We're going to add that 199 to both sides. Alright, so we're going to have, well, it's the same thing. 9y squared plus 18y minus 16x squared plus 64x equals 199. Okay, next we got to factor out a common number. Are there any common numbers? So let's take this 9 out in front. And now it's y squared plus 2y blank. And then we'll take this negative 16 out in front. Now be careful here. This negative 16 is going to come out. It's x squared. 64 divided by negative 16. It's going to change this to a minus 4x blank. Okay. Half of 2 is 1, and 1 squared is 1. So I add 1 here. But it's not just a 1, it's a 1 times 9. So plus 9. Okay. Half of negative 4 is negative 2. Negative 2 squared is positive 4. So a plus 4 here. But this plus 4 is times negative 16. So really that's like negative 16, 32, 48, 64. So it's like really a negative 64. So I have to do that to both sides. Okay. Condense it down. We'll have 9y plus 1 squared minus 16x minus 2 squared. 208 minus 64 is 144. Okay, just like when we were doing the complete the square for ellipses, okay, we had to divide by this because we want this to be a 1. Circles, we like having a big number over here. This would be perfect. Okay, but for ellipses and hyperbolas, we want this to be 1. So we're going to divide everything by 144. So we're going to have a 1 over here. Okay, and then this is usually pretty nice. Okay, negative 16 divided by 144. Maybe it's easier if you think about 144 divided by 16. It's going to be a 9. So it's going to be a 9 on the bottom. And then 144 divided by 9 is obviously going to be 16. We just did the partner of it. All right, and now we're finally there to our equation. Now we can start graphing and labeling all our points. That was a lot of work. Problem, 1 line, 2 line, 3 line, 4 lines of work. Okay, that's expected. That's going to be expected. Maybe we could get away with this one, not doing that one, so that's problem 1 lines, 2 lines, 3 lines, so the problem plus 3 more lines. That's the kind of work we're going to need to see for those. Okay, if you just write down the problem and then write down the equation like this, okay, not going to work. All right, so let's write that down up here. We had y plus 1 squared over 16, x minus 2 squared over 9 equals 1. All right. So our center, now don't be tricked here, the x is back here, so our center is at 2 comma negative 1. Our a is the square root of 9, which is 3. Our b is the square root of 16, which is 4. And our C, come on, you can do it. You can do it without even thinking. Back to geometry, 3, 4. It's a Pythagorean triple, 3, 4, 5. If you want to do it, a squared plus b squared equals c squared, you'll find it's 5. Okay? But this was a nice one, Pythagorean triple. And that only works in the hyperbola ones, because that's the ones where it's a squared plus b squared equals c squared. Every other one, it's not necessarily that. All right. So, center 2, negative 1. This is going to be tricky because they're going by 2, so these are going to be a lot of halfways. Okay, our vertices, which is going to be an up and down one, because the y is first, so the actual vertices here are going to be 4 up and 4 down for my center. 2, 4, down 2, down 4. Those are going to be the actual vertices. Okay, the focus points are going to be 5, so just one more beyond that. Right on the money there. Okay, and our co-vertices, which are going to be our helpers, are 3 to the side. So 2, 3, 2, 3. And remember, those just help us get our box in the middle here. So it's going to go up until we're in the same spot with that one, so it would make like a right angle. And this one, and this one. Okay. Alright, dotted lines, dotted lines, dotted lines for these asymptotes. I always forget and go solid, and that's going to be like a -1/2 on a quiz or a test. Dotted lines there, through the corners. Dotted lines through the corners. Okay, our individual pieces are coming out this way and following up. And down. Okay, so there's the graph. Let's make sure we have all of our information. Our vertices. Okay, we're starting at our center, 2 comma negative 1. This is an up and down one, so the actual vertices that we're using are going to be our y coordinates. That's with our b value, so we're going to be plus and minus 4 to that side, just to the y coordinate. So our vertices should be 2 comma 3 if we add 4, and 2 comma negative 5 if we subtract the 4. 2 comma 3, 2 comma negative 5. Yep, there they are. Our co-vertices, which are just there for helpers, we start at 2 comma negative 1, and that was with our a value side to side. That's a plus or minus 3 to the x. So that is going to be 5 comma negative 1 if we add it, and negative 1 if we subtract it. 5, negative 1, there it is, negative 1, just like what we had. Really nice for focus points when it actually works out to be a nice number. 2, negative 1 was our center. Okay, and this was an up and down one, so we're adding the c plus minus. We're doing that to the y value because it was an up and down one. And our focus points are going to be 2 comma 4 when we add the 5, and 2 comma negative 6 when we subtract the 5. And double check that. 2, 4, and 2, negative 6, just like what we had. Asymptotes. Y equals plus or minus b over a, so that's 4 over 3 times x. Okay. Now we aren't at 0, 0, so we need to go with point slope method. These look like they could be at really nice numbers. I'm not 100% sure. Okay, so if you're not 100% sure, you just do point slope. Alright, so we have to use our center, 2 comma negative 1. So it's y minus negative 1, so that's y plus 1. 4/3 x minus 2. And there's your point slope form. Yeah, I doubt with the 4/3 and only being 2 away that these are both going to be nice. They probably both should not be nice. Okay? So there's that one. All right. We got the same kind of deal on the next one. Okay, why don't we hit pause and give you like a 2 or 3 minute head start here. Let's hit pause and give you a 2 or 3 minute head start to try this one on your own. Okie dokes, welcome back. Okay, so this is another one where you're going to have to be completing some squares. So let's see what we got. Well, we can just look at the one I've already done. Okay. So we're going to have to get our x's together. Okay. Factor out the 4. 4x squared. Now this is just a 6x plus blank. Half of 6 is 3. 3 squared is 9. So we have a plus 9 here. But this is a 9 times 4, 36. I have to have a plus 36 over here. Oh, just see, I added the 4 over there. Make sure you got that. Okay. Factored out the negative, so that's tricky. Factor out the negative. Oh, and I don't think I did that over here. Yep, I missed one. Okay, so this is a negative coming out. So now that's positive, and now this is negative. Okay, so that will come back in right here. So half of negative 4 is negative 2. Negative 2 squared is going to be 4, so we have to have a plus 4 here, but it's 4 times a negative, so it's really a negative 4. So I have to subtract 4 out here. The 4 and the negative 4 will cancel. This will just be 36. This should be y minus 2. Okay. Because I didn't change my negative sign. Right there. Okay. Yep. And then we'll have all this stuff ready to go for our problem. So we'll have x plus 3 squared over 9 minus y minus 2 squared over 36 equals 1. So the x's first, so that means it's a side-to-side one. What other kind of information can I get from this? My center is negative 3, positive 2. My A is 3. My B is 6. So we're going to have to do a little a squared, b squared, c squared action here. So we'll have 9 plus 36 for the square root of 45 for C. You can reduce 9 and 5, so this will be 3 radical 5 for our C value. And just for our purposes, C value there, 3 radical 5 is a 6.7. So if we go to graph this later, we'll see what that does for us. All right, our center is negative 3, positive 2. There's our center. It's a side-to-side one, so my vertices are going to come from A. So 3 to the left and 3 to the right. 1, 2, 3. 1, 2, 3. So there's my actual vertices. My co-vertices are just my helpers. 6 up and 6 down. 2, 4, 6. 2, 4, 6. Okay, and those are only going to be used to help make our little box thing here. And now we can do our asymptotes and dotted lines. I always have to tell myself, otherwise I'll go solid. Dotted lines, dotted lines, dotted lines. Okay, which way is this one going? Side to side. X is first. Okay, so my individual pieces of the hyperbola are going to start here and follow our asymptotes out. 6.7. So 2, 4, 6, and a little more there-ish. Up 6.7 from the center. 2, 4, 6, and a little bit more out there. Okay, so if I'm adding 6.7 to my center, negative 3, 2, then this should be positive 3.7, 2. If I'm subtracting 6.7, this should be negative 9.7, 2. Decimal points, we need to have it written in. Okay, so that's just from the graph. Now we need to have like the answers. If it was like on the side of a quiz or a test, what are the vertices? Okay, your vertices. We start at the center. This was a side-to-side one. So it's going to be going to x. That's our A value, plus and minus 3 there. So we're going to have 0, 2, and negative 6, 2. Our co-vertices, from negative 3, 2, co-vertices, we went up and down. Those were just our helpers. Those are going to be our B's, plus and minus 6. Those are going to go with our Y's. So we had negative 3, 8, and negative 3, negative 4. Focus points. These aren't going to look very pretty. These are going to have the reduced radicals for the answer blank, like on the side of a quiz or a test. Okay, up here on the graph, you can go ahead and give me the decimals, because the decimals are just more practical for graphing. But for the exact, like, mathy answer, we're going to need the reduced radicals on the side of a quiz or a test, where it says, what are the focus points? So again, starting at the center, this was a side-to-side one, so these are going to get added to the x, plus and minus 3 radical 5. So these aren't going to look the prettiest, right? Negative 3 plus 3 radical 5, comma 2. And negative 3 minus 3 radical 5, comma 2. Okay, asymptotes. Y equals plus minus b over a, so that's going to be 6 over 3. That would be helpful for doing it here. Go up 6, out 3, up 6, out 3, down 6, out 3, down 6, out 3. But now that we've already got that stuff in, for our answer on the side of the quiz of the test, this is going to need to be reduced to plus or minus 2 over 1 or just 2x. Okay, that's not done yet because our center was not 0, 0. So how do we account for that not being 0, 0? We got point slope form. This is our slope. We need to put our point in there. So y minus your y1 of your center, so it's y minus 2 plus or minus 2 times x minus x1, your x point from your center. And that was negative 3. So minus a negative 3 would actually be a plus 3 right there. Whew. All right. Lots and lots and lots of fun. Okay? So you're going to have, it's going to be a little bit shorter because I know these take a long time. Okay, we're going to drop that down, so it should just be 5 problems. Okay, we're going to go with page 629, 14 through 22 even. I know there's a lot of problems. Okay, that's a lot of work for those, but it's 5 problems. You can do 5 problems. Okay, so 14, 16, 18, 20, and 22. Not all of them are going to be like that. You're going to have a couple of them like this probably, the first one that are super easy. All right, any kind of work, okay, that's going to need to be shown on a separate piece of paper. All right, and then maybe even you're going to need to have these vertices, covertices, focus points, asymptotes, all written down on a separate sheet of paper. Okay, that's not going to fit on our graph paper. You're going to have that somewhere else. Okay, there you go. We'll see you guys next time. Good luck with that. Let me know if you have any questions.